Right. The other day we talked about sampling or samples and population. Well, now we're going to talk about the sampling methods, the ways that we can get good data, collect good data. So these first several types of samplings are so that we can avoid bias. We want as precise data as we can. So the first one and the most common is a simple random sample, or SRS. That's where every item in the population has an equal chance and likelihood of being selected in the sample. The big example they do is putting or giving every member in a population a number, then using a random number generator. Or we can put all the names onto pieces of paper into a bowl, mix thoroughly, and draw names. And every item in the population has an equal chance of being picked. So that's when we just randomly pick out of the whole thing. That's what we usually think of when we think of random sampling. So you and your friend want a survey to find out how students at LTHS enjoy the cafeteria food. Describe how you can use a simple random sample to gather data. Well, there's a couple different ways. We can write every student's name on a piece of paper, put all the pieces of papers in a hat, mix it around, and choose 10 students and ask them the question. Or every student has an ID number already. So all student ID numbers are put into a spreadsheet, a random number generator is used, and select 10 students to survey. Everyone has the same opportunity of being picked, hence a simple random sample. Simple random sampling is a fundamental sampling method and can easily be a component of a more complex sampling method. So an SRS can be part of another sampling method as well. But again, the most useful, the most straightforward way to sample is names in a hat. Now the next two samplings, sometimes we get mixed up, so I'm going to try and illustrate the difference. The first one is stratified sampling. This is where we branch off the entire population to multiple non-overlapping groups. So what we should also add in there, we group by common characteristics. So we're not just putting them in any groups, we're putting them in groups that they're similar to. All group 1 is red, all group 2 is yellow. All group 1 are people taller than 6 feet, group 2 is between 5.5 feet and 6 feet, and so on. Then, once we split them up into groups, we take an SRS, so just a random grouping of each sample. So our sample is going to include some from group 1, some from group 2, some from group 3, and some from group 4. And the ones that we pick from each group are just randomly taken, put in names in a hat, random number generator, whatever. So there's two things to notice about, maybe I won't write it there. Two things about a stratified sampling. We group on purpose, so we put them in groups based on something, and we take some SRS from each group. So we group on purpose, some common characteristic, and then we take some from each group. So use the cafeteria food survey. How can you use a stratified sample to gather your data? Well, what groups can we split students up into? Well, an easy one would be their year in school. Whoop. So students are stratified into freshmen, sophomores, juniors, and seniors. 10 students of each class are chosen for their sample using an SRS. So we got freshmen, sophomores, juniors, seniors, and the SRS giving us 10 freshmen, 10 sophomores, 10 juniors, 10 seniors. That's stratified sampling. Now Now, cluster sampling, a little bit different. We're a population divided into convenient clusters. Really kind of random groups, wherever they're around, whatever's easiest. And then entire clusters or entire groups are chosen at random. So like we talked about up here, we stratified, we group on purpose and take some from each group. Here, we group randomly and we choose some groups. We do an SRS of the groups, not from each group, but of the groups. So again, we have the same type of diagram here. Say we split up our population into 4 groups. They don't necessarily have to have anything in common. And then we randomly pick whole groups. So we picked group 1 and group 4, and that's our sample. We got everyone in group 1, everyone in group 4. So again, to illustrate the difference, explain how the following picture shows the difference between cluster and stratified sampling. So in the first sample, we can tell, well, maybe we can't tell here too much, but we group these are the same color, these people are the same color, so we grouped them based on common characteristics. We grouped by color. So we got the green group, we got the blue group, and then we took some from each group. We took 2 here and 3 from the dark blue group. Whereas in a cluster sampling, we split it however. Notice there's 2 blues and a green, a blue and 2 greens, 3 blues, 2 blues, a green, and so forth. And then we take whole groups. So we take this whole group and this whole group, and they're just randomly chosen. So another way we can say this, on the stratified side, there are 2 clear groups, the 2 different colors. Then we take some from each group. On the other side, we grouped, just mixed up, just grouped however they were standing, and then we took whole groups. Next one is stratified, or sorry, systematic. A systematic is a system, has a rule. You start with 1 member chosen at random using an SRS from a population, and then you rule such as every 3rd member, every 5th member, every 10th member to select members, so every so often. If you've flown, a very good example is the TSA screening. Maybe they'll take every 10th person and they'll wand them or send them to the body scanner or whatever. So using the cafeteria food survey, how can you use a systematic sample to gather your data? So suppose we would start here. Then if we're choosing every 3rd person, it'd be 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. So those 5 would be on our sample, and they're every 3rd person. So how can we use this to survey about the cafeteria food? As students are sitting in the cafeteria, we just take every 5th person sitting at the tables until we get 20 students. The nice thing about systematic is we don't need to know how many there are total. In cluster, we needed to group them up. We needed to group them, so we need to know how many there were, whether it's grouping by color or grouping randomly. With systematic, we don't need to know how many total there are. We just kind of keep taking people out of our sample using our rule until we get what we need. Now these samples are not good samples. These are high risk of bias, meaning our data will not be precise. the measures that we get from our sample will not be representative of our population. First one is convenience sampling. It's literally where whatever's the easiest to get, we choose them for our sample, and that's what we use. Our convenience sample here, we can see this person who's colored in black, and we have the blue and the red. They're all just kind of spread out. They're different colors, doesn't really matter. But then we just choose the 5 people right next to the person that we're talking about. They're right there. So really, again, it's not a good sampling method, but it's just whatever's easiest. So why you think convenience sampling has a strong risk of bias? By choosing only those that are convenient, you're not getting a random sample. Again, if we're sitting in class and I choose the 5 people sitting around me, they could be my friends because they're sitting around me. And so that doesn't have a good representation of everybody in the class. Using the cafeteria food survey, again, we're going to mention friends again. Not the show, but the noun. You simply only survey your friends because they'll be convenient to do so. Or sample only students in one of your classes, like I was saying. So convenience literally is just the easiest to do. Self-selecting sampling is where the sample is made up of volunteers. People volunteer their answer or themselves to be in a study or a survey. Now, there's a lot of bias in self-selected sampling. Because think about who volunteers to give an opinion. People who have strong opinions, either for or against whatever we're talking about. Somebody who's indifferent, they're not going to even answer. Do you like the Cubs or the Sox? And if you don't like sports, you're like, I don't care. I'm not going to even answer. It doesn't matter. Who's going to answer? Big Sox fans and big Cubs fans. So oftentimes people that volunteer to take a survey have a strong opinion. So for example, in college, students will receive course surveys regarding their classes and instructors. Students that choose to do the survey will most likely be students who either love the class and the instructor or strongly dislike the class and the instructor. If they're indifferent, they're like, what's the point? I'm not going to fill it out. It doesn't matter. Using the cafeteria food survey, how can you use self-selected sample to gather your data? All students have an email, so you decide to create a Google form and send it out to all students asking them to take the survey. So those who choose to take the time to do the survey will most likely have a strong opinion on the cafeteria food. They either really, really love it, which I can't see happening, or they really, really, really hate it. But if you're indifferent, you're like, yeah, the food's good sometimes, but sometimes it's not. I'm not going to fill out the survey. All right. What sampling method is used in the following examples? Is the method likely to be biased? So letter A, starting with a randomly chosen ID number, every 5th ID number was chosen and that student was asked to fill out a survey. Every 5th. That's our rule. That's a system. So when we have a rule and we're keeping the same every 3rd, every 5th, every 4th person, we're talking about systematic sampling. The rule's every 5th person. And it's unlikely to be biased. It's a pretty good sampling method. Now, retailer put feedback cards at the front of its store. They got responses from 22% of its customers. Now, there was no randomness there. Hence, there's going to be bias. And this is a self-selected sample. People who want to pick up the feedback cards will fill them out, and they either really had a good trip to the store, they bought what they needed, or they didn't. They couldn't find what they wanted, and they're upset, and they're going to let them know. Letter C, a city wants to know what % of people in a city own a dog or a cat. A city worker goes door to door in the neighborhood around City Hall to ask people about their pets. So again, there's no randomness, so there's going to be bias. And the city worker is just going door to door in the neighborhood around City Hall. It's what's easiest. or a convenience sampling. And again, it's biased because pets might be more or less common in other parts of the city. Maybe if you're in a downtown area, don't have as many pets, or maybe not as many dogs, and out in the suburbs, there'll be more dogs. So where you take it does make a difference. Lastly, experiments. We talked about experiments earlier. Well, in an experiment, we have, for the most part, two groups. An experimental group that receives the treatment we're studying. This is the group that changes, that we give the new drug, or we give the actual medicine. The control group would be a placebo or a fake treatment, or common or whatever's already used. So no change. The experimental group, we change something. Control group, we keep the same. Design an experiment for the following scenarios. What is the treatment of the experimental group and control group? All right, pharmaceutical company wants to design an experiment to determine the results of a new flu drug. So randomly select a sample into two groups, all of which have the flu. So they have to have the flu or else the new drug isn't going to do anything anyways. The experimental group will receive the new flu medicine. The control group will not. Maybe they get a placebo, a fake shot. So they may think they have it, but they don't. And then analyze the results. And lastly, a new coffee brand wants to see if their coffee improves memory because they know this will be good for marketing. If you remember something better, yeah, it's going to sell. So we get a random sample of people. Again, it's got to be a good random sample to eliminate bias. Everyone takes a memory test at the beginning. Then for some period of time, the experimental group drinks their coffee, and the control group does not. Again, maybe they get a placebo, maybe they get tea, or soda, or pop. I don't know why I called it soda, but they're given something else, or not giving anything. The memory test is given again, and compare the results. So we changed the group that had the coffee to see if it makes a difference. The other group we kept the same. Whatever their normal process was, we did. And that's 8.2.